Let it snow, let it snow, let it snow.
It's December and I want it to snow, at least on my computer screen, in a window kind of like this. And let's just enlarge it once again. This is what I've got. Snowflakes are gently falling with wind towards the ground, where they lie as simple snowflakes that are 1 pixel each. And it gets gradually distributed a long way. And I've added text. And as you can see, there's something going on with the responsiveness. It's not too cool. But I was thinking something more fun than fixing that would be figure out how can I put snow on the text. I want it to land everywhere on the text. So today I'm going to look into that. First, let's revisit how the snow actually lands. Here's a beautifully drawn M, but let's ignore that for a moment. Here's the ground, and continues in X direction, and that is at position max Y. So a snowflake that falls would fall from the top and down, and when it reaches something greater than or equal to max Y, then it lands. There's also the landed array, but let's ignore that for a moment. When snow should land on a letter, it should say, okay, if it falls down and there's no letter, then it just goes all the way to max Y. But if it goes here, and that's the letter, it should stop here, and it should stop here. But then when there's what's called a slope here, for every pixel it would stop a bit further down, and so on and so forth. So I would need a lot of different Y positions rather than max Y, where a snowflake could stop. And I already do have something a bit similar in the landed array. Because that would be, say, there could be 1 snowflake, then there could be 2 in the next, and there could be 3, and then there could be another with 3, and so forth. And that would be a pattern, say 1, 2, 3, 3, 3, 2. That actually looks like a 2.5. Yeah, never mind. So if I could have an array kind of similar to this, like I would call it letter top, that would say, okay, here it would be 0, 0, 0, 0, or maybe it would be max Y. Or nothing. I'm not sure what I should set it at. Yeah, just say max Y. And then suddenly it would be here. Let's just say that's at position 100. And then there would be a lot of hundreds and 100 and 100. And suddenly we have one here that's a bit further down, so that would be 101 and 102 and so on. So before checking for max Y and the max Y minus landed, I should also check for this letter top array, and if a snowflake is at position letter top, it should land. I cannot, however, use the greater than or equal to letter top, because if a snowflake was flowing in, say it was flowing in here, in like there, because of the wind, here, that would be greater than or equal to this, but it should not land here. So I can only check equal if it's just precisely at, but I think that's okay. Some snowflakes might skip over, but I think the effect will be fine. So my challenge now is, how do I create this letter top array? Well, the letters, they are drawn onto the canvas as the very first thing before the snow. And if I take a look, it would look something like this. It's a fake screenshot, but you get the idea. And if I then could somehow go from the outmost X position, scan all the way down, see is there any pixels here? No, they're all transparent. The next X position, scan all the way down. There's no pixels there. And the next one, in the completely straight lines. And the next one, and then it would say, oh, here's a pixel that is non-transparent. So now I have a value. And then I will go to the next one and say, oh, there's another value. And so on. So if I could scan all the pixels of this image, this canvas image, before any snow was added, I would find the tops here. And I can do that. In the documentation, there is something here on pixel manipulation. And there's an image data object that represents the underlying pixel data of an area of a canvas object. There's a width, there's a height, and then there's data. And that's called a uint8 clamped array, representing a one-dimensional array containing the data in the RGBA order with integer values between 0 and 255. And it could not be clearer, or could it? Let's just let's go and make another drawing. Here we have an array of pixels, all perfectly square, with a width of 1, 2, 3, 4, 5, and a height of 1, 2, 3, 4. And that would have a one-dimensional array R of a lot of values. I'm just drawing the pixels here. 1, 2,
3, with comma in between them, of course.
And that will be all in all 20 pixels here. 20 pixels, 20 positions in the array, and array length of 20. Because 1, 2, 3, 4,
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
So easy peasy. But then say we want this pixel. Where's that in the array? Well, first we have to find the X value. X, where is it here? And the Y value, where is it here? And this one up here is not position 1 in X or Y, it's position 0. 0, 0, because everything is 0 indexed in computer science. So this means that the Y position of this would be 1. This row is 0. This one is 1. Y is 1. And X would be 0, 1, 2. And then we could do the calculation. Say index would be position Y times the width, because every time we have a width, it would be 5 more. This would be 0, 1, 2, 3, 4, 5. 1 times 5. Here, Y times width plus X. So this one would be 1 times 5. I'm writing it here. 1 times 5 plus 2 equal to 7. That would be at index 7. So that would be 0, 1, 2, 3, 4, 5, 6, 7 here. We could also count them, say 0, 1, 2, 3, 4, 5, 6, 7. Yes, position 7 would be this. Easy. So that was the first part. But if we look here, it says that data is in RGBA format. That means that we don't have just one. This is not just one, it's actually 4 values. We have this one would be, the first value would be R, the next would be G, that's the red, the green, the blue, and alpha, the A value. So it wouldn't be 20, the 20 pixels wouldn't be 20 values, it would be 80, because each of them would be 4. So that would be 0 here, and then 4, and then 8, and then 12, and then 16, and 20, and 24, and 28. How do we do that? Could we just say 7 times 4? Yes, we can. So we just say 4 times all of this. Then we have the index. Cool. So now we just have to code it. Let's see if there's an example we can copy. Is there something? Creating an image data object. That's not what we want. Here, we can get the image data, left, top, width, and height. Let's use that. And then find our code. We have to do it here. Analyze the image. Let my image data, and we want from 0, we want all of it. We want config max width, that would be max x, and we want all the height, config max y. And then loop through every x value. So I'm creating a for loop from x to, say, just in case, let's go to my image data dot width x plus plus, and then inside here we are going to loop through every y value on this x. Like here, we go through every x, and for every x we go down to through every y. So that would be another for loop. For let y be 0, and let y be, as long as it's smaller than the height. And then we can get the R value. That would be my image data at let's find our index. Our index would be, as I calculated, 4 times y times, can I just have it here? 4 times, and I have to parenthesis everything, y times the width plus x, and then R would be my image data dot, what is it called? Because get image data gives me, it's called data. Oh, fun. So data index And then I could say R would be this, G, B, A, index plus 1, plus 2, plus 3. And I would only need something that isn't transparent. And I can't for the life of me remember the value of A when it's transparent or not. So I'm going to console log it for this x comma y. A is, and A would be that, and x comma y. I'm just writing these %d for digits, I think it's called. And then I can write the values here, x comma y comma a. And let's just see what happens. It's 0, 0, 0. That must be when it's transparent. Okay, apparently I broke it by using all these console logs. But I noticed that if A is 0, then it's transparent. So I just want to say if A is different from 0, then we have a non-transparent pixel at position x comma y. So I need to store it somewhere. That was my, I want to call my letter tops. And that should be an array that just have for every x position, it should have the first letter top. So I'm going to say letter tops at position x is the value of y. And then I need to stop. Then I say, okay, no more y's. I don't want to hear about it. So break. And that should break me out of the while loop and get another x. And then this one should be global. It should be outside. So I'm going to move it here. Let's see how that works. Letter top is not defined because it's letter tops. Okay, interesting. Letter tops. And can I see? Okay, so at position 29 it begins. Okay, so that's a problem. I need to clear it first. So I'm just going here at the beginning, setting letter tops to config.maxy. And then it should say 427. I think that's max y. And it changes here at position 29. Does that kind of match my, this one here would be, yeah, it looks like it. At X position 29, it changes. So there's the top. Cool. So now I just need the snowflakes to land there. And that would be in my land snowflake. Here, no, it wouldn't, because it would be up here when I check if this is the height. But first, check if landed on a letter top. If this dot ypos, I can't use ypos because that's a decimal number. I have to round it off. So let y be math.floor, this dot ypos, and then say if y is equal to, that would then be letter tops of this index, then land on letter. And then the land snowflake, what does that do? Yeah, that gives me a landed XX plus. I can't really use that now. So I'm just going to copy everything and say X I have and Y I have, and I can't increment that yet. And then just say okay, I need to fill it with X, that would be my index, comma my Y position, comma 1, comma 1. So this should land on letter tops. Only one snowflake, I don't count them yet. Let's see what happens. Yay! The snow lands on the tops and on the slopes, and it goes round here. Oh, this is wonderful, this is wonderful. Well, it's also been a very, very long episode, so I'm going to commit. Snow landing on letters. Tomorrow I'll see if I can get the snow to stack at the top of the letters rather than just have a single thin line of snow. See you then.
Let it snow.